Welcome to Machine Arena, where the sparks of industry still burn bright. Today, we journey through the world of steel, fire, and precision. A story of how raw power becomes tools, machines, and objects we use every day. We begin our journey into the world of heavy industry, where strength and fire combine to forge the backbone of modern life. This plant alone has the capacity to produce more than 7 million tons of steel each year, a figure that recalls the great American mills that once powered our railroads, bridges, and skyscrapers. Inside towering furnaces, iron and scrap metal are melted together at extreme temperatures, purified of impurities, and reborn as new steel. The molten liquid glows like the heart of the sun, guided through channels and molds with careful precision. Sparks fly as machines and workers collaborate, shaping the foundation of tools, machines, and structures. From this fiery rebirth, steel begins its timeless journey. From molten steel, we now move to the powerful process of shaping. In massive rolling mills, glowing ingots are pressed and stretched into precise forms. With each pass through the rollers, the steel is transformed, its inner grain aligned, its strength enhanced, and its surface smoothed to near perfection. These colossal machines operate with precision, using reversing stands and sliding cages to handle the enormous pressure. The process is continuous, seamless, and carefully monitored by skilled specialists. Heat, sound, and vibration combine here into a true symphony of industry. A reminder of the living power within steel. Modern automation ensures remarkable consistency. Sensors, control systems, and powerful motors work in harmony, guaranteeing that every roll, every cut is exact. Yet, no matter how advanced the technology, the human touch remains irreplaceable. Experts oversee each stage, adjusting for temperature, alignment, and flow. A single misstep could compromise strength, but with experience and care, the results are flawless. As the ingots pass again and again, thick masses of steel are gradually reduced into thinner, flatter products. Wide slabs, beams, and strips emerge, destined for countless industries, from construction and automotive to heavy machinery. Each glowing bar is a story of transformation, shaped by fire, guided by machines, perfected by hands. When the steel finally cools, we witness the culmination of an extraordinary journey. What began as molten fire now lies before us as structured, engineered perfection, steel ready to support skyscrapers, endure the force of locomotives, or form the hidden strength behind bridges and machines. It is a testament to the enduring craft of shaping raw energy into human achievement. From steel bars to finished wheels, the journey begins with cutting the raw ingots into manageable pieces. Each billet is heated until glowing, its surface cleaned of scale to prepare for forging. Next comes the immense press, a 9,000-ton giant that forges the steel into rough wheel shapes. Additional drilling is carried out on a 5,000-ton press, ensuring precise dimensions before the form is refined further. The wheel then moves to specialized rolling machines, where it is expanded and shaped into its final profile. A hot stamp is applied for traceability, followed by a meticulous laser measurement to verify accuracy. Through transfer tunnels, the wheel enters the heat treatment furnace, where controlled heating and cooling enhance durability and strength. Once treated, the wheel is cut, and a sample is taken for laboratory testing. Here, impact resistance is tested, chemical composition is analyzed, and metallurgical properties are examined. Automated ultrasonic systems scan for hidden flaws, while hardness tests confirm resilience. Machining refines every surface, followed by magnetic particle inspections to detect imperfections invisible to the eye. Visual and dimensional checks add another layer of assurance. Finally, the wheel receives protective coatings and color spraying, giving both function and finish. This is the complete process of crafting a steel wheel, from raw billet to a component strong enough to carry the weight of industry and transport, tested at every stage to guarantee safety and reliability. Here, precision meets innovation. Massive steel rings, forged under immense heat and pressure, are now placed into advanced turning machines. Unlike the thunder of forging hammers, this stage is calm, but no less demanding. Cutting tools glide steadily across the surface, shaving away fine layers with astonishing accuracy. Every pass is measured, every movement deliberate, ensuring tolerances that exceed even the strictest standards. The recorded precision is remarkable, with run-out and center position deviations controlled to less than 15 microns, thinner than a human hair. Such accuracy is vital, for these rings will one day serve in turbines, engines, or heavy machinery where failure is not an option. It is a marriage of engineering and craftsmanship, proving that true strength is found in both power and precision. Now we enter the world of heavy forging, a place where sheer force, fire, and precision combine to create some of the largest industrial components on Earth. Here, colossal shafts and massive parts are given form, destined for power plants, ships, and heavy machinery. The journey begins with the cutting of raw steel blocks. Gigantic saws slice through tons of solid metal, separating each section for its specific task. The sound is deep and steady, a reminder of the patience required when working with material so dense and strong. Once cut, these immense pieces are ready for transformation. Heating follows. The steel is carefully cooled, hardened, and tempered in controlled stages, building the strength needed to withstand decades of relentless stress. Unlike small-scale blacksmithing, every adjustment here requires machinery on a monumental scale, furnaces that can hold entire car-sized shafts, and quenching systems that regulate temperature with absolute precision. After heat treatment, the shafts are transferred to massive lathes. Here, turning begins. The once rough forms are spun and shaped into exact dimensions. Sparks fly as sharp tools carve away steel, producing smooth, balanced surfaces. Precision is key. One fraction of a millimeter can determine whether the shaft will succeed or fail under enormous pressure. Drilling comes next, as specialized machines bore deep into the core or ends of the shaft. This ensures proper alignment for future assembly, whether into turbines, generators, or heavy construction equipment. The drilling process requires both stability and accuracy, balancing brute force with delicate measurement. But strength alone is not enough. Each forged piece must pass non-destructive testing, examinations that reveal flaws without harming the part itself. Ultrasonic waves, magnetic particle inspections, and radiographic scans probe deep into the steel, searching for cracks or weaknesses invisible to the human eye. These tests guarantee that only components of absolute integrity move forward. Laser measurement follows, confirming that every surface and diameter meets exacting standards. The shafts, now weighing many tons but shaped with micrometer accuracy, are prepared for their final stage. Packaging such giants requires heavy cranes, specialized rigs, and careful handling. Steel this strong may seem indestructible, but precision demands protection during transport. Finally, the forged shafts are loaded and dispatched. Trucks, trains, and ships carry them to their destinations, where they will disappear into the inner workings of modern industry. We may never see them again, Yet they will power turbines, turn generators, and support massive structures for decades to come. This process is more than just steelwork. It is the continuation of a legacy. In America's great industrial heartlands, similar scenes once defined daily life. Workers in Pittsburgh, Cleveland, and Bethlehem built their livelihoods around forges, mills, and lathes. Though many of those plants have fallen silent, their spirit endures in places like this, where the combination of strength and precision still defines human progress. From cutting to cooling, turning to drilling, testing to transport, every step embodies the union of power and discipline. This is heavy forging at its finest, a discipline that takes fire and force and turns them into enduring strength that will serve generations to come. Steel does not always emerge as massive shafts or wheels. Much of its importance lies in the finer details, in sheets, strips, and coils that quietly power countless industries. Here, we witness the slitting process, where huge coils of steel are unwound and cut into perfectly measured strips. Rotating blades shear through the metal with astonishing speed and accuracy, slicing the wide rolls into narrower bands. Each strip must be flawless, flat, smooth, and consistent, because these products will later become the hidden framework of appliances, automobiles, and machines we rely on daily. The operation may look effortless, but it is a science of balance and precision. Sensors monitor alignment, powerful motors regulate tension, and skilled operators oversee the entire system. Even the smallest variation could compromise quality, making human judgment just as critical as automation. Once cut, the steel is recoiled, stacked, and prepared for shipment. From here it travels to factories where it will be stamped, welded, and transformed into products that define modern life. It is a reminder that industry is not only about monumental objects, but also about the unseen, reliable details that quietly hold our world together. From raw steel, we now move into the world of craftsmanship. Few creations capture the human spirit as deeply as a finely made knife. Simple in form, yet powerful in purpose, the knife has accompanied humanity since the earliest days of survival. And in modern industry, its making remains a blend of tradition and innovation. The process begins with forged blanks, pieces of steel heated to glowing red and pressed into rough knife shapes. Centuries ago, blacksmiths would hammer out blades by hand, but today, immense presses perform this first shaping with incredible force and consistency. Once formed, these blanks are heated again, preparing the steel for grinding. On the grinding line, sparks fly as machines carve the first edges into the steel. Slowly, the lifeless blank begins to reveal its identity as a blade. Each grinding pass defines its geometry, laying the foundation for sharpness and balance. What once was raw steel now hints at its purpose, a cutting edge that must be both strong and precise. From grinding, the blades move to polishing, tempering, and sharpening. Polishing smooths the surface, while tempering strengthens the core, balancing hardness with flexibility. Without tempering, the blade might cut cleanly but shatter under stress. Without polishing, it would lack refinement. Each step is carefully measured, ensuring resilience, durability, and the ability to hold a razor edge. Thousands of blades pass along conveyors, moving steadily through stations where automation and human skill work together. Robotic arms transfer blades, while workers inspect with trained eyes. Machines provide speed and consistency, but judgment still belongs to the craftsman. Every blade is stamped for traceability, then tested for sharpness. A blade that fails the test is returned for correction, ensuring that only excellence moves forward. The journey continues to the handle. Handles are more than decoration. They provide grip, balance, and safety. Each handle must fit the blade perfectly, bonded with care, and then shaped for comfort. Here, human touch is irreplaceable. Skilled workers sand, adjust, and refine each handle, guaranteeing that the knife feels natural in the hand. Final inspections follow. Professional craftsmen resharpen and finish blades, paying close attention to the smallest details. Even after machines have done their work, it is the human hand that confirms the knife's worth. The process may yield thousands of knives in a day, but each one is treated as a tool meant to last. Watching these knives emerge reminds us that industry is not only about heavy machines and roaring furnaces, it is also about the quiet dignity of tools that serve daily life. In kitchens, workshops, and farms, knives remain essential, a bridge between modern manufacturing and timeless tradition. Here, steel is not just shaped into function, it is shaped into legacy. Every blade carries within it centuries of knowledge, skill, and pride, proof that even in an age of automation, craftsmanship still defines the true spirit of steel. The journey begins with large steel sheets being fed into massive stamping machines. With immense pressure, the machines press out rough blanks, the early forms of each scissor half. Skilled workers swiftly collect and arrange these blanks into trays, preparing them for the next stage. Each half is then taken to grinding machines, where high-speed wheels shape the rough edges. Sparks fly as the steel slowly transforms into a recognizable blade profile. From there, the surfaces are polished, removing scratches and giving a smooth, clean finish before moving into the crucial heat treatment stage. In this stage, the steel is heated in furnaces until it glows red hot, then quenched in cooling tanks. This process of hardening and tempering ensures that the metal gains strength and durability while retaining the capacity to be sharpened to a razor edge. Technicians monitor every cycle carefully, ensuring temperature and timing remain precise. Once hardened, the blades undergo another round of fine grinding and polishing. Now, the cutting edges take shape, gradually honed until they are capable of slicing with ease. Some blades are tested immediately, checked for alignment and cutting accuracy, while others are set aside for additional surface treatments. Next comes assembly. Workers carefully align two halves of the scissor, joining them with rivets or screws to form a central pivot. This joint is critical, as it determines how smoothly the blades move across one another. The pivot is tightened to exact torque, allowing the blades to glide effortlessly without losing cutting strength. Attention then shifts to the handles. Made from plastics or composite materials, the handles are molded in specialized machines. Each handle is designed for comfort, offering a secure grip during use. The freshly molded handles are pressed onto the steel tangs where they are permanently fixed in place. Any excess material is trimmed away, leaving a neat and ergonomic finish. After assembly, the scissors are subjected to a series of rigorous quality checks. Edges are sharpened once more, ensuring every pair meets the standard of razor-like sharpness. Some factories even employ automated machines to test cutting performance on different materials, paper, fabric, or thin plastic sheets. Workers then perform a visual inspection, looking for flaws, blemishes, or alignment issues. Finally, each pair of scissors is polished to a shine, cleaned of any oils, and neatly packaged. Rows upon rows of completed scissors are placed into boxes, ready to be shipped across the world. What may seem like a simple household item is, in reality, the product of a detailed and highly engineered process. From stamping and heat treatment to polishing, riveting, and final inspection, every step contributes to creating a tool that is sharp, reliable, and built to last. This is the art and science behind the making of scissors, a humble object, yet one crafted with remarkable care and precision. From fire to forge, from steel to tools, we've seen how industry shapes the world we live in. Thank you for watching. If you enjoyed this journey, please like, share, and subscribe for more.